Okay, so here's quiz number 7. And we're talking about confidence intervals. So it says a magazine provided results from a poll of 500 adults who were asked to identify their favorite pie. Among the 500 respondents, 12% chose chocolate, and the margin of error was given at plus or minus 3 percentage points. Now what does that mean? If you take 12% plus or minus 3%, 12 minus 3% is 9%, and 12 plus 3% is 15%. We're saying that somewhere between 9 and 15% is probably the true percentage of the whole, United States, I guess, who like chocolate pie as their favorite kind of pie. Does that make sense what they're saying? When they say they did a study, they only asked 500 people, so they didn't ask the whole United States. They just asked 500 people. And for those but what they want to get at is the truth of the whole United States. So I'm assuming. I'm just going to, I don't know if it's the whole world. I doubt it. Different cultures are going to have really different tastes. So I'm assuming this is America. So 500. So they asked 500 adults. This pie company. They want to know, which pie is most popular for what they should produce. Asked 500 adults, and 12% said chocolate was their favorite. But there's a margin of error, right? Because when you ask 500 people, that's not everybody in the United States, and you might get a little bit of a weird group. You might get a group who likes chocolate pie more than the average people in the United States, or less. A group that just doesn't like chocolate pie quite as much as most people in the United States like chocolate pie. Who knows? That's why the plus or minus, that's the margin of error. They know that. Like when they do a poll, when they're trying to figure out who's going to win president 6 months before the national election, they will say, 12% are going to vote for candidate A. A margin of error was plus or minus 3%, meaning our little poll, our little 500 people we talked to, 12% are going to vote for candidate A, but we know that there could be an error. That's probably not the real percentage for the whole nation on election day, but it's close. So there's an error, meaning the real number on election day is going to be either 3% more than that or 3% less than that number we got in our little group of 500 people from our sample. That's what they're saying here. So for chocolate pie, 12% in their little group of 500 like chocolate pie best. That's their favorite kind of pie. But they know there's a margin of error plus or minus 3%. So if you subtract 3% and add 3%, that means the true percentage for the whole United States is somewhere between 9% and 15%, right? That's 12 minus 3 and 12 plus 3. The true percentage for the whole nation who like chocolate pie as their favorite must be between 9% and 15%. We're pretty confident. Now, how sure are we? Because there could always be a drastic error. Those could have just been 500 chocolate pie haters by just random luck. You just got 500 people that just really don't like chocolate pie, or they could be 500 chocolate pie lovers and you just got really lucky. Either way, it's really lucky, really strange. That could happen, but when you talk to 500 people, it's not very likely that you're going to get a really lucky sample. If you only talk to 10 people, there'd be a bigger chance of getting that lucky. But 500 people, that's what we're wondering about here. That's what this chapter is all about. We want an interval of confidence. We want to say the true percentage for the whole nation of people who like chocolate pie as their favorite pie is somewhere between 9 and 15%, right? 12% minus 3% or plus 3%. Somewhere between 9 and 15%. Now, if maybe that's a 95% confidence interval, CI, confidence interval. In other words, we're 95% sure. What that means, let me make sure we're clear on that. We're 95% confident that the true, real percent for the whole United States is in the interval 9 to 15%. That's what a confidence interval is. You're certain percentage sure, 95% confident that the true, real percentage for the whole United States is somewhere in that interval. So this is they didn't say it's 95, but let me just throw that number out there. Let's say this is a 95% confidence interval. We're 95% sure that the real population is in that zone. Now, what if you tried to take that same study, that same data, the same 500 people, and the fact that 12% said they like chocolate pie best? What if you didn't need to be so sure? So we wanted to be 95%. That's pretty sure here. And so we gave and take 3%. But what if you only wanted to be 80% confident? You know, not as sure, not as confident. Well, because what do we really think, right? The 500 people we asked, exactly 12% of the 500 people, right? For the 500 we sampled, exactly 12% of them like chocolate pie best. But we're not sure this is the same for the whole United States. And if we wanted to be 95% sure, we realized we needed to subtract 3% and add 3%. Make it a little wider. Say, hey, it's not right in the middle at 12. We're 95% sure it's between 9% and 15%. But if you only needed to be 80% confident, less confident, then maybe you could subtract only 2 and add only 2. So you could say, hey, we think it's between 10% and 14%. That's a more narrow, lower percent confidence, more narrow. Do you see what I mean? If you only need to be 8, I'm just guessing at the 2. You might want, where do you get the 2? Where do you think? I'm making those up. Don't worry about those. I'm just wanting you to get the big idea, the general concept that if you want to be really sure, 95%, then you got to take a wider interval. If you want to be really sure that you've got the true percentage, you can't say, well, it's right at 12. I'm just sure it's 12 because my sample of 500 came out 12% like chocolate pie best. Well, those 500 might be different than the whole United States. So you gotta say it's around 12%. You got to go below 12% and above 12% in a kind of wide range, down 3, up 3, saying I'm 95. I'm really sure it's between 9 and 15 because that's 3 below the 12 and 3 above the 12. But if you don't need to be so sure, if you want to be less sure, say I'm 80% sure that, again, I think it's 12 right on the money, but I'll just go a little below the 12 and a little above the 12. Maybe just 1 below the 12 and 1. I think it above the 12. Maybe it's, between, what would that be, 11% and 13%. So I'm just throwing out for instances, maybe 11 and 13 or 10 and 14. Those are more narrow, closer to the 12. If you don't need to be so sure, if you can be less sure, you're going to have a more narrow interval. But if you want to be more sure, like I'm really sure we got it, you got to be a wider interval. You got to give more room for error. So the answer to this question then is this one. A 95% confidence interval must be wider than an 80% in order to be more confident that it captures the true value. That's what we're talking about. If this didn't make sense, listen to it a couple of times. Okay, so here we are on number 2. Study the accuracy of fast food drive-through restaurants. Restaurant A had 279 accurate orders, 73 that were not accurate. Construct a 90% confidence interval estimate of the percentage of orders that are not accurate. They want these, in other words, not accurate. Okay, so basically, long story short, this restaurant had 279 that were accurate and 73 that were not. So we always have to figure out n, which is the total number. So add those up on your calculator and you get 352. So there's 352 orders, and 279 were done accurately, 73 were not done accurately. And what we're looking for is to make a 90% confidence interval for the percentage of orders that are not accurate? Like what percentage of orders are not accurate? We could just divide, 73 out of 352, and we would get, if you did that in your calculator, you would get like 20.21, like about 21% of the orders. Boy, that's pretty bad, isn't it? That restaurant's messing up 21% of their orders. But anyway, that would tell us 21%, right? 73 out of 352 total. That's 21% of their orders are messed up, are not accurate. But that would just be from our sample, right? That's our sample of 352 orders. From our sample of 352 orders, 21% were not accurate. But what we want to know is what this restaurant does overall, not just on the particular 352 orders we grabbed. We want to know, hey, what's the real percentage that they do not accurately? And you think, well, 21%, that's our best guess. Yeah, that is our best guess, but we need an interval around that because we don't know, because the real value might be a little higher or a little lower because of the fact that we just grabbed 352 orders. We could have got a little bit lucky and the real truth is the restaurant does a little better than that on average or a little worse than that on average. So we want an interval. We want to be 90% sure from what? Maybe from 18% to 23% is the real true. I'm just guessing right now, and I'll show you how to figure it out in a minute. Just want to give you the feel first off. We're just guessing, like what is the range, the interval, the zone in which we would find the true percentage for all orders that this restaurant will ever crank out. What true percentage of orders are not accurate? What's the true percentage? Somewhere around the 21%. If we want to be 90% confident, how much around the 21% do we have to get? Well, to do that, we're going to use our TI calculator. And here's the steps. This is exam 3 notes, which again is on the Canvas course for my online students. And for my face-to-face students, I'll pass it out or email it to you. So I'm on number 2, question 2 on the exam 3 notes, confidence intervals. P or percentage, that's what we're trying to figure out. You've got to go, so up here you're going to have to hit the stat button and then go over to tests. So hit stat and tests and then go down to find 1 proportion Z. I should have said 1 proportion Z. Oh yeah, it did. 1 proportion Z interval. Don't grab the 1 proportion Z test. Don't get the test. We'll do that later. That's coming later. Do the 1 proportion Z interval and hit enter. Once you've got that. And it'll ask you a bunch of questions. It'll ask you X bar. First off, let me go back when you see that. So it'll ask you X. I'm sorry, it's not X. It's just X. So that's going to be the number. What did I say it was here? Number asked for. Number in this case, not accurate, right? Because that's what they said. They said percentage of orders that are not accurate. So 73. That's going to be 73. Next, it has N. N is the total number of orders. N always means total number, 350. And everything we're going to do in statistics this point forward. The confidence level, what level did they want? 0.9, right? 90% confidence interval. And then just go down to the calculate and hit enter. And what you'll get is an interval that goes from 0.172, rounded to 3 places, to 0.243. It says rounded to 3 places. That means we're 90% confident that the truth of this restaurant is somewhere between 17% and 24%. Remember, we estimated 21%. And that is the middle of those two. and we asked, but we don't know it's exactly 20. It was exactly 21% of our sample, but we don't know that for all orders ever for this restaurant, it's really 21% not accurate. We're 90% confident, though, it's somewhere between 17% and 24%. Okay, and now they go on to restaurant B, and they say restaurant B is somewhere between 18% and 25% not accurate. So which restaurant's better? So this is restaurant A, somewhere in there. B is somewhere between 18% and looks like 26% roughly, taking this number and just rounding them. So A is somewhere between 17 and 24, B is somewhere between 18 and 26. Which one's better? Well, there's just a ton of overlap, huh? We'll just choose A here. Since the two confidence intervals overlap, neither restaurant appears to be real different. They're about the same. Okay, question 2. Survey of 3,308 adults aged 57 through 85 years old. It was found that 80.2% of them use at least one prescription medication. Prescription medication. All right, so how many of the 3,308 subjects use one prescription medication? How many of them? How do we figure that out? It says 80.2%. Change that to a decimal. That percentage of the 3,308 people, right? There's 3,308 people, and 80.2% of them use the medication, at least one prescription medication. So what is of in math always? It's multiply, isn't it? So we multiply those, and I'm getting 2653.016, but we just round it because you can't have part of a person. So it's 2653. Then it wants me to make a 90% confidence interval. So we know how to do that. Let's go back to it. 1 proportion Z goes stats. 1 proportion Z goes stat. 1 proportion Z interval. And we choose X to be the number, which would be the 2653. And what else do we have here? We have N, and N will be how many total? 3,308. Remember, N is always the total number in the study. The 2653 is the number that do whatever we're talking about. In this case, use at least one prescription medication out of 3,308 total adults that were surveyed. And the confidence level is 0.9. Hit enter under the calculate, and you'll get the number 79. Oh, they want a percentage. So 79.1% to 81.3 when you change to percentage. And then their final question, what do the results tell us about the proportion of college students? College students? These are not typically college students. The results tell us nothing about college students because we're talking about older people. So they're just making sure you're paying attention to the words there. Okay, number 4 here is kind of tricky. You're operations manager for an airline. You're wanting to hire fare level for passengers in aisle seats. How many randomly selected air passengers must you survey? You want to be 90% confident that the sample is correct within 3.5 percentage points of the true population. So this is a whole area of statistics. It's kind of tricky for people. We're going to figure out N. So I've given you some formulas here. Let me go over here with you to the formulas. I'm on exam 3 notes, clearly. Sample size, finding N. That's what we're doing, right? We want to find N. Assume that nothing is known about the percentage. Sample P unknown. That's what we're doing right here. So N will be that formula. Let me write it out here. So for part A, N equals, what is it? Z squared times 0.25 over E squared. Okay, so what are those things? Well, the Z is found here in the table. What's our level? We're trying to be 99% confident. 99%, there's your z. So grab that z value. That's your z. You just grab it from the table. So you'll have these notes with you on the exam, and you can just use this table for whenever you get an in question. So the z is 2.575, 829, 303. Now it says squared. How do you do that in the calculator? You don't need, forget about these parentheses, you don't need them. You do up arrow 2. I'm going to show you exactly how you enter this on the TI calculator. Up arrow 2, and then times the 0.25, and then divided by, just hit the divide button, and then the E, what's the E? It's this, but be careful. E is 3.5%, remember? So that makes the decimal go back 2 places when you take off the decimal. You always have to take off the percentage. You always have to take off the percentage. So 0.035, let me write that a little neater here. 0.035, but what? It says squared to the second power. And then you got all that, hit enter. And when you do, what do you get? You get 13. I got 1354.06053. But then notice what it says. Round up. Up. Now, up means up. It's not round off. You notice you don't round to the closest. That's called rounding off. They're not saying round off. They're saying round up, and they mean it. So you need to go to 1355. You might say, well, Mr. Aaron, it's closer to 1354. It is, but they said round up. Now, why would we want to round up? We're trying to figure out, that's our answer to part A there. We're trying to figure out how many people we need to talk to in this survey to get the kind of results we want, the confidence level and air and accuracy that we want. Well, basically, more people always produces stronger data. That's why we round up. We need to talk to exactly 1354.06. Well, you can't talk to 0.06 of a person, so you talk to another person, and you get more accuracy. So that's part A. They mean round up. Whenever you do in, notice the table here. They all say round answer up, round answer up, round answer up. Always. Okay, so now let's do part B. Part B is almost the same, but it says now assume instead of nothing is known like part A. Part B, assume that prior survey suggested about 30 ahead of time. You think about 34%. So you think your P, the percentage that prefer an aisle seat, is about 0.34. Well, if you go to this formula, so now sample P known. Now I'm going to do that. First find Q, which is 1 minus P. It's the opposite. It's like chance of rain, chance it won't rain, opposite. 34% chance of rain, then that'd be what? 66% chance it won't rain. It's the opposite. So find P and Q. See how I'm getting that? They gave me the P right there. That's the P, whatever percentage they give you. Whereas in part A, they didn't give me any percentage. That's why nothing is known. But in part B, they gave me a percentage. And then I found Q, 1 minus P, that's what the formula says, and then plug into your in formula right there. So now N equals, I already forgot, what is it? Z squared PQ over E squared. Z squared PQ over E squared. It's almost the same. So Z squared, same exact Z. Exactly. Well, are we doing the same percentage? Yeah, exactly the same. We're just still doing 99%. So grab that. That's our Z. 2.575, 829, 303, exactly the same. Squared, that's Z squared, times P, 0.34, times Q, and then divided by, and then e squared, exactly the same thing here, 0.035 to the second power. Hit enter, and the answer you should get, answer I got is, let me see, 1215.4. Goes on and on, but we're supposed to round up. Remember, always up. Talking to more people is always better. More accurate data, 1216. That's the answer. Okay, so use these formulas from your exam 3 notes to do those problems. Okay, so here we are on number 5. A clinical trial was conducted to test the effectiveness of a new drug for treating insomnia in older subjects. Before the treatment, 22 subjects had a mean wake time of 101.0 minutes. In other words, before they got this drug, their average wake time, mean is average, right? Average wake time of 101 minutes. That's a lot. That's almost 2 hours, right? 160 minutes in every hour, so 2 hours would be 120 minutes. That's almost 2 hours. These older folks are awake every night on average almost 2 hours. Insomnia, that must be terrible. Okay, so that's before the drug. After treatment, so they're given the drug now. After treatment, the 22 subjects had a mean wake time of 91.6. So it went down. It's not great. I guess it went down 10 minutes. You know, it's the average before was 101. Now it's 91. It's about 10 minutes. So it gave them 10 less minutes of wake time. I'm not sure that's so great. Standard deviation at 23.9. Of course, there was variation, deviation. Assume that the 22 sample values were from a normally distributed population. Like, you know, it's always the bell curve thing. Construct a 99% confidence interval estimate of the mean wake time for the population with drug treatments. Okay, so here we go to confidence interval. This one again, right? Got to go through this stuff. So let's do it. Whoops, let's do it. So we're going to find the 1 proportion z interval under the stat tests. So go there, and under the, you go to stat, go to test, go down to 1 proportion z interval. I'm having trouble getting there. There we go. And then it'll ask you for an x, an n. So what's the x? What's the number of minutes of wake time? 91.6. That's after the drug. We're trying to find out what the drug does. We don't care about the original 101. That was before they'd been given this drug. So now it's, I'm supposed to make that a, whoops, I just realized I'm doing the wrong thing. It's not a 1 proportion z, because it's not a proportion. That's what got me all of a sudden. I was saying, wait a minute, this isn't a percentage, is it? 91.6 is not a percentage. It's not saying 91.6%. It's saying their mean wake time after the drug was 91.6 minutes. So in other words, I've got to go back over here, and I'm doing the mean. I'm doing confidence intervals now for a mean, not a percentage. Okay, so now we're doing no data given. We'll do a data one in a minute. This is no data given, so choose T interval and stats. So let's do that. So let me get rid of this. This was all wrong. So we're going to go to stats, tests, and then we'll choose T interval. We're choosing T interval instead of 1 proportion Z interval because it's not proportions. It's mean, right? It's mean. It's mean right there. T interval, or is it, yeah, T interval. So you choose T interval, and then choose stats. Instead, it has the data and the stats option. Choose stats, highlight stats, and then it'll ask you for X bar. X bar is the average, the mean, 91.6. It'll ask you for S sub X, standard deviation, that's the 23.9. It'll ask you for N, that's 22. That's always the total number of people in the study. And of course the confidence level, they want a 99%. And then hit enter under calculate. And you'll get your numbers. And what it comes out to be is 70 rounded to one decimal place, 77.2 to 106.0 rounded to one place past the decimal, 106.0. So, okay, so what is that really saying then? So this is a different kind of confidence interval, isn't it? Let's go back and look at the notes again. Here's the notes. If you have a confidence interval that's for a percentage, you do the 1 proportion z interval. If you have a confidence interval that's for mean, you got to do either this or we'll do the other one in a minute. No data given, t interval, choose stats, x bar, sx, and n. It's because it's for a mean, not a p, a percentage or proportion. It's a mean. Right? It's a mean right here. All right, now what does this mean? We are 99% confident that what this drug really does. Remember that people took this drug so they would have less wake time, right? They have insomnia. They're awake during the night. They took this drug so they would have less wake time during the night. Well, now that they've taken this drug, the average, the mean, was 91.6 minutes. But, you know, this is just 22 people. We don't know this is what the drug does to all people. That's what we want to know. We want to know what's the real effect of this drug on all people who will ever take it. That's always what we're interested in statistics, is the true effect of things, drugs, or an election coming up, or, you know, we want the truth. What's really going to happen? What does this thing really do? And so we take a sample, like 22 people or whatever, find out what it does to them, and then we form a confidence interval. So we're 99% confident that the real drug will have an effect on people so that their wake time will be between 77 minutes and 106 minutes, 77.2 and 106.0. That'll be the mean wake time for all people who will ever take the drug. We're 99% confident. So what does this suggest about the mean wake time of 101 minutes before the treatment, right? Before they took the drug at all, they had an average wake time of 101 minutes. So is this drug helping a lot? Are we confident it's helping? No. Because the 101 minutes, that's in our interval. That's between, whoops, I'm not writing that very neatly. 101 is between 77.2 and 106.0, right? 101 is between 77 and 106. Right? And we're 99% confident that the drug will give you a mean wake time between 77 and 106 minutes. Well, they already had a mean wake time of 101 minutes, so maybe the drug's doing nothing. Right? We're 99% sure the real effect of the drug is going to be somewhere between 77 minutes of wake time and 106. Well, they already had 101 minutes of wake time before they took the drug, so we're not even confident this drug's doing anything. That's what it suggests. The confidence interval includes the mean wake time of 101, right? The 101 is in this interval. It includes it. The 101 is between 77 and 106. It includes it before the treatment. So the mean before and after the treatment could be the same. Right? Maybe it's doing nothing. The means before and after treatment, the average wake time before treatment was 101. After treatment, we're saying we're 99% sure it'll be somewhere between 77 and 106. It could be 101. It could be the same. Right? Because 101's in that interval. We're saying it's some number between 77 and 106. We don't know what. We're 99% sure that the true effect of the drug is going to be some number between 77 minutes of wake time and 106. Well, 101 is in that interval. It could be 101. It could be the drug's doing nothing. So because the interval includes the mean wake time of 101, it could be the same. The mean wake time afterwards could be the same. This result suggests that the drug treatment does not have a significant effect. Okay, number 6, a food safety guideline is that mercury in fish should be below 1 part per million. Listed below are the amounts of mercury found in tuna sushi sampled at different stores in a major city. Construct a 98% confidence interval estimate of the mean amount of mercury in the population. Does it appear there's too much mercury in tuna sushi? All right, so this time they're giving us, they want a confidence interval. Do you see do you see percentages anywhere? I mean, of course, it's a 98% confidence interval. We always have that. But are they giving us percentages on this problem? No. These are means. This is the average amount, right? This is the amount of mercury in parts per million in tuna sushi at different restaurants around town. So this is the mean amount, the average amount. These are not percentages, in other words, right? Right? It's not like back here on number 4, or let's go back even to number 3, where it said 80.2% of them, right? Not only did we have the confidence level, but we're talking about what percentage of them use the medication. It's not what we're doing here. We're talking about means. Okay, and they're giving us data. Means with data. So this is data, isn't it? So let's go to our class notes. Here's their exam 3 notes, Exam 3 notes. Confidence intervals. This time we're in mean data given. We're down here. So enter the data into L1. Right? Put the data in L1. So first thing, put this data into L1. There's step number 1. So step 1. Put that data in L1. Step 2, what does it say? So put the data in L1. T interval, choose data. So, you're going to go stat, test, T interval, and then you're going to choose the data box this time. Data box. So step 1. Let's make sure we're clear here. Step 1, data into L1. Data into L1. Step 2, go to stat, test, T interval, choose data. Under list, you should have L1. Remember how, if it's not L1, change it to L1. Remember how to do that? You had to hit second and 1, and it'll make it L1. Frequency, if you have that on your calculator, just keep that at 1. That's how frequently each of the numbers in the list is listed. It's just once. And the C level, the confidence level, they're telling us to do a what? 98%. So 0.98 and hit enter on calculate, and you'll get, I got point rounded to 3 decimal places, 0.295 and 1.194 as the answers. So I'm just using these steps. So use those exam notes for exam number 3. Okay, now, does it appear that there is too much mercury in tuna sushi? Is there too much? What does this result mean? Let's be clear. Here they're testing if we really understand what this even means. That's almost the most important part, because in real life, you might not do a lot of statistical studies, but you'll read them. A lot of jobs, we're consumer culture. We're information age, right? There's information coming at us all the time. We need to know how to understand. So that's probably the most important part of this question. What does this mean? Well, we are 98% confident, and write that here. We are 98% confident that the true average mercury in the tuna stuff is between 0.295, this number, and 1.194, whatever ppm, parts per million. So we're 98% confident that the real number, the true number that's out there, for all, for this city, for this major city, maybe Fresno, whatever, major city, for all the tuna sushi in the city, they grabbed, a few different major stores in this major city, and we calculated a 98% confidence interval, so we're 98% confident that the true average amount of mercury in the tuna sushi in this major city is between 0.295 and 1.194 parts per million. Now, remember what they said. It should be below 1 part per million. You don't want it above 1. We're 98% confident it's between 0.295 and which is like 0.3, and this is like 1.2. It's between 0.3 and 1.2. Uh-oh. So it could be over 1, couldn't it? We're 98% confident it's somewhere between 0.3 and 1.2, which means it could be 1.1 or 1.0, right? It's supposed to be, you wanted it to be below 1 part per million. Uh-oh. So what does that mean? C. Does it appear that there's too much mercury? Yes, because it is possible that the mean is greater than 1, right? It's somewhere between 0.3 and 1.2. It could be more than 1. Also, at least one of the sample values exceeds 1, right? This one exceeded 1. So at least some of the fish have too much mercury. Okay. An IQ test is designed so that the mean is 100 and the standard deviation is 22 for the population of normal adults. Find the sample size necessary to estimate IQ score of statistics students such that it can be said with 90% confidence that the sample mean is within 8 IQ points of the true mean. Assume that sigma equals 22 and determine the required sample size using technology. Okay. Well, they want sample size. Let's go to our exam 3 notes. Sample size. This is number 1 on exam 3 notes. Now, are we doing a percentage or a mean? Mean. Huh. So here we are. There's our formula. Okay, so N equals Z, what was it? ZSE times S over E, the whole thing squared. Did I get that right? ZS over E, the whole thing squared, right? Okay, and so here we go. What's the Z? The Z comes from the percentage. What's our percentage here? 90%. 90%. Z equals what? 90%. There it is. 1.644. 1.644. 853. 626, wasn't it? Yeah. Okay, so just grab that number. That's our Z. All right, let's put it in. Here we go. Well, here's how you type it into your calculator. You type in a parenthesis and then the Z. Or no, you don't. Oh, yeah, you do need that. 1.644. You know what? I've noticed parentheses confuse students. So let's just make this easy. Make this easy as I can for you. 1.644, 853. Don't worry about the parentheses. I'll show you a trick. 626, and then times the S, right? S comes next. What's the standard deviation? What's that? Oh, that's the 22. Yeah, right there. Standard deviation 22. It's 22 divided by E. Now, what's E? E means air. That's the 8. 8 IQ points. The mean is within. So that's the air, right? You know, you want to. The air is the air level. You know, the estimate is within 8 IQ points of the real thing. It's within that amount of air. So that's 8. And when you're done with all that, just hit enter. I know we haven't done this part yet. Just hit enter. And then, just when you're all done, go to the second power, and it'll grab the last answer. Or you can do second answer if you want to, but it'll grab it. You don't have to the second power and hit enter. That way you won't have to mess with parentheses. It'll be easier. And when you do all that, I got the answer. I get 20.46. But then remember, we always round all these round up, because talking to more people, more in your sample is always better. 21. So you should talk to 21 people if you want to estimate statistics students' IQs with 90% confident within 8 IQ points. You want to estimate the true average IQ of all statistics students. You better talk to 21 of them, measure their IQ, and you can be 90% confident of the real true average IQ of all statistics students within 8 IQ points. Would it be reasonable to sample this number? Yes. This number of IQs is a fairly small number. We could do that reasonably. There's the end of the quiz.